Number 9. Show that the equation of tangent theta plus 60 equals to 2 cotangent theta can be written in the form. Okay, yeah. Using the tangent formula, tangent theta plus 60 is equals to 2 cotangent theta, ya. Nah, the formula is tangent theta plus tangent 60 divided by 1 minus tangent theta tangent 60 equals to 2 cotangent theta. So tangent theta plus square root 3, 1 minus square root 3 tangent theta equals to 2, 1 over tangent theta. Nah, cross multiply, ya. So 2 tangent square theta plus 2 root 3 tangent theta equals to no 2 here equals to 2 1 minus square root 3 tangent theta. So it's tangent square theta plus square root 3 tangent theta equals to 2 minus 2 square root 3 tangent theta equals to tangent square theta plus 3 square root 3 tangent theta minus 2 equals to 0. Proven, ya. B. Solve for theta between 0 until 180. So that means we just need to use the formula, ya. So tangent theta is minus 3 root 3 plus minus square root 3 root 3 square minus 4, 1, negative 2. Yeah, using the quadratic formula divided by 2. So it's negative 3 root 3 plus square root of 27 plus 8. Square root of 35, yeah. So minus 3 plus square root of 35 over 2, or tangent theta equals to negative 3 square root 3 minus square root 35 over 2. Now, using the calculator, you will have the result. Theta is 19.8 degree. And in here, the theta is negative, ya. Negative means in second quadrant. Tangent negative in second quadrant, 100.2 degree. Yeah, there are two answers. One in the first quadrant and the other one in the second quadrant. Let f show that the derivative of f is smaller than 0. Okay, so we have to derive dy dx. Now, this is division, so we need the quotient rule, u over v. So u is cos x, u prime is negative sin x, v is 1 plus sin x, v prime cos x, ya. So dy dx is u prime v minus uv prime per v square. So u prime negative sin x, 1 plus sin x, minus UV prime cos square x, yeah? Cos x times cos x. Divide by v square, 1 plus sine x square. Dah. And then simplify negative sine x minus sine square x minus cos square x over 1 plus sine x square. This is minus sine x minus 1, sine square x plus cos square x over 1 minus sine x square, plus square sine x square equals to minus sine x minus 1, yeah, over 1 plus sine x square, or this is equals to minus sine x minus 1 plus 1, yeah, 1 plus sine x square. Oh, we can cross, and this is equals to 1 over 1 plus sine x. Now, since x is between negative half pi until 3 over 2 pi, that means it's from the fourth quadrant, turn around until the third quadrant. So this will be negative in the first and second quadrant. So in Q1 and Q2 are always negative. Ya kan? Because of the negative sign in front of the expression. In Q3 and Q4, sin x is always negative, yeah. So this is greater than minus 1 until 0. Now, therefore, 1 plus sin x will be always positive. So therefore, negative 1 over minus 1 plus sin x is always negative. Is smaller than 0. Yeah, so we have proven that the first derivative is always negative in all the quadrants. B. Find integral. Simplify the exact form. Okay, so integral cos x per 1 plus sin x dx. Now this is substitution because the numerator is the derivative of the denominator. So we put the denominator as the u. U is 1 plus sin x. Du over dx is cos x dx. See? Cos x dx is equal to this. So we can just simply change it. Yeah. Equals to integral 1 over u and then change into du. So it's ln u. Put the border, yeah, the boundaries. Now the boundaries here are for x. Now, because we have u, so we can change the boundaries in terms of u. Yeah. So for x equals to 1 over 6 pi. So if we replace it this function, we will have u equals to 1 plus sine 1 over 6 pi, which is 3 over 2. And for x equals to 1 over 2 pi. 1 over 2 pi, that means u is 1 plus sine 1 over 2 pi, which is 2. So the boundaries are from 3 over 2 until 2. So that means ln 2 minus ln 3 over 2. Can we simplify? We can use this formula. Ln A minus ln B equals to ln A over B. So we can have ln 2 over 3 over 2 equals to ln 4 over 3. This is the final answer. Number 11. By differentiating cos x over sin x, show that if y equals to cotangent x, then the derivative is negative cosecant square x. Okay, so this is u over v, yeah? So dy dx, u prime v minus uv prime over v squared. U is cos x, u prime is negative sin x, v is sin x, v prime is cos x. So put into the formula, u prime v, negative sin x becomes sin square x, minus with u v prime. So cos x times cos x become cos square x. Then over v square. V square is sin square x. So this is negative bracket sin square x minus cos square x plus, yeah, over sin square x equals to minus 1 over sin square x. So this is minus cosecant square x. Show that integral x cosecant square x equals to this. Now, we have to use the integration by parts. So according to the rules, so we will have this as u and this as dv. Yeah, u is x, du is dx, dv is cosecant square x dx, and v equals to, now integral of cosecant square x, we can use the answer number 1. Integral of this is this, but because it doesn't contain the negative, so that means this is, we put negative here, cotangent x. Yeah, see from here, the negative here, the derivative should be include the negative, but since in here we don't have any negative, so we put the negative in front of the cotangent. Nah, and then we just put into the formula, uv minus integral v du. So uv, so negative x cotangent x minus integral negative cotangent x dx. So this is negative x cotangent x plus integral cotangent x dx. So this is the same like when we integrated tangent, yeah? We have to find the integral of cotangent first. Now we can use cotangent is cos x over sin x dx. Using the substitution, I just make u as the denominator, yeah? Sin x. So du is cos x dx. So again, I have integral 1 over u, and then cos x dx is equals to du. Yeah, just change it into du. So this is equals to ln u. Again, okay. So this is ln sin x, yeah. So we can have the final answer here, minus x cotangent x plus integral cotangent is ln sin x. And then we put the boundaries 1 over 4 pi, 1 over 2 pi. What is this? Okay, bracket negative 1 over 2 pi cotangent 1 over 2 pi minus jadi plus 1 over 4 pi cotangent 1 over 4 pi plus ln sine 1 over 2 pi minus ln sine 1 over 4 pi. Yeah, the absolute sign, the absolute sign they did in the ln. So to make sure that there is no negative in the function ln. Yeah, I give the line here. So what is this? What is cotangent 1 over 2 pi? Cotangent 90 degree. Tangent 90 degree is infinite, right? So cotangent of 90 degree, 1 over infinity is 0. So this is 1 over infinity, which is 0. Plus cotangent 1 over 4. Tangent 1 over 4 is 1. So it's 1 over 4 pi. Plus sine half pi is 1. So this is ln 1. Minus ln sine over 1 over 4 pi is half square root of 2. So ln half square root of 2. So the final answer is 1 over 4 pi minus ln half square root of 2. Okay, we change into the ln 4. How do we change that? Minus, this is 2 to the power of half over 2. So 1 over 4 pi minus ln 2 to the power of negative half equals to 1 over 4 minus plus half ln 2, or this is equals to 1 over 4 plus 1 over 4 ln 4. Yeah. So we make the 2 here become half times half ln 2 square. So this is the same thing. Yeah. And this leads us to this. Now we have the same expression. So equals to 1 over 4. I forget the pi. Pi plus ln 4. Yeah. Number 12. Let I, using the substitution, okay, we replace the x. So integral square root of cos square theta 1 minus cos square theta dx. Now, dx should be changed into d theta. So using this, we can find the dx. dx is 2 cos theta times negative sin theta d theta, or negative 2 cos theta sin theta d theta. So I can change dx into negative 2 cos theta, sin theta, d theta. Now, what can we have here? We can have integral square root of cos square theta over 1 minus cos square theta is sin square theta times minus 2 cos theta sin theta d theta. So that means the result of the square root is just cos theta over sin theta. Okay, I just put negative 2 in front and then cos theta sin theta d theta. Okay, I can cross this cos. So it's negative 2 integral cos square theta d theta. Now, it's still negative 2, yeah? But let's us check the border. The border for x is are 1 over 4 and 3 over 4. So when x equals to 1 over 4, that means 1 over 4 equals to cos square theta. So cos theta is plus minus 1 over 2. Yeah, cos theta is plus minus 1 over 2. So the theta should be cos inverse of 1 over 2 is pi over 3. We take the positive value, yeah, since the theta in here should be in the first quadrant. When x equals to 3 over 4, yeah, x should be positive in here, yeah. The theta will be 3 over 4 equals to cos square theta. So the same thing, cos theta is 1 over 2 square root of 3. So which is theta is 2, 1 over 6 pi. Now, that means the border is from pi over 3 until pi over 6. But in here, it's the way around. So we have to switch it. Now, when we switch the border, yeah, it become negative. So it's become positive, pi over 6, pi over 3, cos square theta d theta. Yeah, so this is the same. Yeah, always take the theta in here, positive in the first quadrant. Yeah, I hence find the exact value of I. So just integrate this. Now, using the identity of cos 2 theta equals to 2 cos square theta minus 1. So cos square theta is cos 2 theta plus 1 over 2. So we can use it here. 2 integral cos 2 theta plus 1 over 2 d theta. Cos the 2. So this is become half sine 2 theta plus theta. Put the border pi over 6, pi over 3. So this is equals to half sine 2 pi over 3 minus sine 2 pi over 6 plus pi over 3 minus pi over 6 equals to half 2 pi over 3, yeah, is sine 1 over 3, half square root 3 minus this is sine 1 over 3. So the same thing, yeah, plus 1 over 6 pi. So that means this is only 1 over 6 pi. This is the final answer. Number 13. By first expanding sine 2x plus x, show that sine 3x equals to 3 sine x minus 4 sine cube x. So sine 2x plus x. Yeah, using the formula, this is sine 2x cos x plus cos 2x sine x. So that means sine 3x equals to, now, we will change all in the single x here. So all the double angles should be changed into single angle. So sine 2x is 2 sine x cos x plus cos 2x. In here we see that we need the sine cube. So we can change the cos 2x using the sine, which become 1 minus 2 sine square x sine x. Simplify 2 sine x cos square x plus sine x minus 2 sine cube x. Now, the cos square here change again into sine. 1 minus sine square x plus sine x minus 2 sine cube x. So 2 sine x minus 2 sine cube x plus sine x minus 2 sine 3x equals to 3 sine x minus 4 sine cube x. Proven, yeah? Hence, showing all the necessary working, find the exact volume of value of this. Now, integral sine cube x dx is, we can use our answer in here. Yeah. So what is sine cube x? So sine cube x is, yeah, this is sine 3x. So that means sine cube x is 3 sine x minus sine 3x over 4. Yeah, using this answer. So equals to 1 over 4, 3 cos x negative plus 1 over 3 cos 3x. Put the limit 0 until 1 over 3 pi. So 1 over 4 minus 3 cos 1 over 3 pi plus 1 over 3 cos 3 times 1 over 3 pi minus, put the bracket again, negative 3 cos 0 plus 1 over 3 cos 0. Now cos 0 is 1, yeah, not 0. So negative 3 cos 1 over 3 pi is half. Plus cos pi is negative 1. Minus cos 0 is 1, negative 3 plus 1 over 3. So 1 over 4, negative 3 over 2, minus 1 over 3. Minus 8 over 3. Yeah? Don't forget to put the bracket here. So 1 over 4. This is negative 11 over 6 minus plus 8 over 3. 1 over 4, negative 11 over 6 plus 16 over 6. So 5, yeah? 5 over 24. Yeah, this is the answer.